have studied how to write algorithms and those things, how to write the algorithms, then categorization of the algorithms, about the efficiency of an algorithm, these efficiency analysis methods, factors which will decide the efficiency of the algorithms, and how to select the best algorithm for a given task. Then asymptotic analysis, then asymptotic notation. After that we have discussed about the big O notation, then omega notation and the theta notation, right? Then today we have to discuss about the greedy algorithms, right? Then this is an approach of algorithm. In this approach, the decisions are made from the given solution domain. Because this is greedy, the closest solution which seems to provide an optimum solution is chosen in this algorithmic method. Always, greedy algorithms try to find a localized optimum solution which may eventually lead to globally optimized solutions. Generally, these greedy algorithms do not provide globally optimized solutions. Right? This is a brief introduction about the greedy algorithms. We'll take an example for the greedy algorithm. Then if we take the greedy algorithmic approach, greedy approach forces the algorithm to pick the largest possible coin, because this example is about coin handling, right? Then imagine if you are provided coins of with the dollar value of 1, 2, 5 and 10, and you are asked to count $18. Then you have to count the $18 using this greedy procedure, right? Then the greedy procedure will be select one $10 coin, then you have to select another $5 coin, then select a $2 coin, then select $1 coin. Using these 4 coins, you can get the $18, right? If we get the 10 plus 5 plus 2 plus 1, then it forms the $18. But if we change the problem slightly, then the same approach may not be able to produce the same optimum result, right? As an example, if we change the currency system, where we have the coins of 1, 7 and 10 values. If the coins are having only 1, 7 and 10, counting coins for the value to get the value of 18 will be absolutely optimum. But to count a value like 50, it may use more coins than the required ones. Right? As an example, if only coins of the values 1, 7 and 10 are provided, to get the 15, you have to select one $10 coin and 5 $1 coins. Then the total coins become 6. Then the same problem could be solved using only 3 coins, 7 plus 7 plus 1. Then at the very beginning of this slide, I told you greedy approach forces the algorithm to pick the largest possible coin. Therefore, the largest value is 10, then you have to select the 10. Then after selecting 10, you have to get only ones, because depending on the availability. Then the greedy approach picks an immediate optimal solution and may fail where global optimization is a major concern. We take this is the characteristic feature of the greedy approach. Then it picks an immediate optimized solution and it fails where global optimization is a major concern. Then we'll move on to the next slide, that is about divide and conquer. Then if we consider the divide and conquer, this approach, in this approach, the problem in hand is divided into smaller sub-problems, and then each problem is solved independently. Right? The big problem is a bigger one, then it will be divided into smaller sub-problems, and the sub-problems will solve independently. Dividing sub-problems into smaller sub-problems, even smaller sub-problems, then this will reach a stage where no more division is possible. Then this no more division is possible stage is called as atomic, and it is the smallest possible sub-problem to be solved. The solution of all sub-problem is finally merged in order to obtain the solution of an original. That's how the divide and conquer. If we take the divide and conquer, it's a three-step process. These three steps are divide or the break, then conquer or the solve, finally merge or the combine. These are the three steps of divide and conquer. If we consider the divide step, this step involves breaking the problem into smaller sub-problems. And this step generally takes recursive approach to divide the problem until no sub-problem is further divisible. Recursive means what? Recursive means what? Can someone hear me and tell what is recursive? No answer. Can you hear me or not?
Yes, madam, we can hear.
Right. Then recursive is it happens continuously until no division. According to this situation, no division is required. It will take place continuously, right? Depending on this division, no further division is required after reaching the atomic stage. At this stage, sub-problems become atomic in nature but still represent some part of the actual problem. That is a major requirement. The sub-problem or the sub-part should represent the actual problem. Then when we consider the conquer stage, this step receives a lot of smaller sub-problems to be solved. Then at this level, the problems are considered solved on their own, right? Then merge. When the smaller sub-problems are solved, this stage recursively combines them until they formulate a solution of the original problem. This algorithmic approach works recursively, and conquer and merge steps work to close that they appear as one. Right? Merge will combine the solutions given for the sub-problems and formulate the final solution for the given original problem. Then there are computer algorithms which are based on divide and conquer, and you will learn about these in next few sessions. One is in most of the occasions this is dealing with sorting. Sorting is dealing with arrays. What do we do using sort? If we consider an array, why do we use sort? Then why do we use sort?
To arrange data in a format as what we want.
Arranging the data or the values stored in the array can be numeric or character values. Then to arrange them in a particular order, usually in the default order is the ascending. If we want, we can arrange them in descending order as well. Anyway, to order the values stored in the array, we use the sorting, right? Then merge sort is a sorting technique. Quick sort is also another sorting technique. Last week also, I think I have discussed with you about this search for an example. Then binary search is an example. I have taken this as an example in the last session as well. Then binary search is based on divide and conquer. Then closest pair algorithm is also based on divide and conquer. Anyway, you don't have to worry much about these things except this closest pair algorithm. Mainly I'll be discussing this binary search because searching is also there. Then sorting also I'll be discussing. Right, that's about this divide and conquer. Then this is about the basics of the algorithms. Then we'll move on to the next presentation. If you have any questions about this divide and conquer and those things, you can ask. Otherwise, we'll directly move on to the next presentation about the terms used in data structure. If there are no problems, then directly we will be moving on to the next one. This is about the basic concepts used in the data structures and algorithms. We'll consider what is data. Actually, data. If we take the term data, before giving this definition, can someone tell me whether this term data, is it plural or singular?
Plural.
Plural. Then what is the singular form of that?
Collection of data.
Not the collection of data. Data is plural, that is true. It's good. Then singular form is called as the datum. Right? Today I came across this earlier. I too thought this as singular and plural both are same data, but today I came across an article because data is plural but singular form is the data. Anyway, here we are dealing about this data. Then if we give the definition about data, this can be defined as a representation of facts, concepts or instructions in a formalized manner, and which should be suitable for communication, interpretation or processing by human or electronic machines. Right, it's a kind of a definition given for data. Then data is used for information. After processing data, we get the information, right? Data is like a raw material. Then when we represent data with the help of characters of the alphabet. Then as an example, capital A to Z or simple A to Z. Then using the alphabet. Then as an example of the alphabet. Then of the alphabet. Then as a then we can represent it using digits 0 to 9 or special characters. That's how we can represent data. Then if we take data, there are characteristics of the data. Those characteristics can be given as atomic, traceable, accurate, clear, or concise. Right? Then atomic means a single concept. Traceable. Then traceable means it should be able to map to some data element. Accurate. That means this should be unambiguous, clear, and concise. It means this should be understandable. Those are the characteristics of data. Then we come across this term called as data object. Data object will represent an object having data. Then we will have the term called as data type. This data type is a way to classify various types of data. As an example, integer string. Right? String is considered as a data type in some languages, but this is not considered as a data type in languages like Java, right? So anyway, in C++, string is considered as a data type. Am I correct? You have studied about C++. Please tell me whether string is yes, okay. Then this data type will determine the values that can be used with the corresponding type of data. Then the type of operations which can be performed on the corresponding type of the data. Then data types can be divided into two. One is called built-in type, the other one is called as the derived type. If we consider the built-in type, these data types, these are the data types for which a language has built-in support. Right? If a language is providing a built-in support for a data type, then that is called as a built-in data type. As examples, integers, boolean, floating point, characters, and strings. All are falling under built-in data types. Then the derived data types. These are implemented independent as their implementation is independent as they can be implemented in one or the other way. Then it is called as derived data types. Usually they are built by the combination of primary or built-in data types and associated operations on them. If we take the list is an derived data type. Then array is a derived data type. Then in future sessions, you will learn about the stack and queue. Then both stack and queue are also derived data types. Then in later sessions, we'll discuss about these basic operations possible with the data structures. They are the traversing, searching, insert, delete, sort, and merge. Some of the terms are familiar with you, but these terms we'll be discussing in next sessions individually, right? That's about the today's session. Then next day, I'm planning to start about the operations of the array. Discuss about the operations of the array. Then if you have any question, then you can ask. Now tell me whether all the students, I can see only 24 students are participating for this session. Then there are around 90 students in the classroom, Ned.
Yes, madam, about 87.
87. Then why don't the others participate? What are the problems with them?
Madam, usually this amount of students are attending to the online lectures because some of others have some connection problems and some of them don't have laptop or a smartphone, just like things.
Smartphone is also not available. That is.
Yes, yes, but some people have smartphones, but they don't have enough coverage to access video conferencing. Just I don't know. Many people have different problems.
Anyway, we'll wind up the session for today. Then, right, rather than wasting time, then we'll wind up the session for today, right? Okay,
Thank you, madam.
right.